Yeah, thank you for the very kind introduction. Today I want to talk to you about hallucinations and AI literacy. And first of all, I have some good news for you. The good news is I'm not trying to sell you anything. Instead, I come with a gift, but there's a catch. The catch is that you've already paid for the gift yourself because we are funded by the government, so you've already paid it in taxes. The Toolbox Datenkompetenz, which basically means Toolbox Data Literacy or Data Skills, is a government-funded project, and it's part of the data and digital strategy of the German government. And the aim is to increase data literacy in our society. And we conduct this project together with the Institute of Applied Computer Science in Leipzig, and my company, that's StackFuel, that's an e-learning provider from Berlin. And together we first try to understand what's the current situation in Germany with data skills and AI skills, where do we need to go, and how can we go there. And on the practical side, what we are doing is we are building a free tool and education platform. I've shown you a small snippet here. We provide roughly 100 free courses. We have data sets. We have a programming environment integrated into our platform and continuously work on our platform. So, why should anyone care about AI and data literacy? I've shown you a very, let's say, basic AI maturity model just to make the case that wherever you are on your journey towards AI, it's a topic that you should care about. Whether you're a company that's trying to adopt the first use cases, or whether you try to drive adoption in your company, or if you're already an AI-first company or try to become one, at each stage you should care about AI literacy and data literacy. And one part is actually, that's also a big topic today, and yesterday as well, is the EU AI Act with Article 4, where it's explicitly said that every company needs to ensure that people building AI tools, using AI tools, and maintaining AI tools have a sufficient degree of AI literacy. So, what we're going to discuss today is I will give you a short introduction to AI literacy. Probably everyone here knows what AI is, but we'll still discuss it a little bit. And we will talk about what AI literacy is. And then I try to give you some examples and some arguments why we need it by showing you what can happen if we don't have it, what can go wrong. So first of all, a couple of years ago, if you would go to anyone in the society and ask them what is AI, they would have a perception that's probably shaped by science fiction. So I tried to put one AI example for each of the past generations. Maybe you got a first contact in Space Odyssey and met HAL 9000. Maybe you met the Terminator. Maybe you met the agents from the Matrix. Or maybe you met Ultron from the Avengers. These are all examples of AI depicted in our entertainment. And they all share that they're not really, let's say, kind towards humanity, and it can create some kind of fear in the general public. But today, AI is everywhere. It's not science fiction anymore. Everywhere we turn, every company is now an AI company. Everyone is using Gen AI, so we must adapt our concept of AI, but we also need to take into account that some people in our companies, in our society, in our families might have some kind of resistance towards AI because they are framed by these not so positive examples. So let's also address the elephant in the room. What put AI at the front of everyone's mind? It's the sounding success of ChatGPT and OpenAI. This is, as far to the best of my knowledge, the fastest adoption of any technology that we've ever seen. This hockey stick development was never seen before, not with Google, not with Facebook, not with any other technology, as far as I know it. And it changed the whole landscape. So, but what is AI? And sometimes it seems that AI is some kind of black magic that's hard to understand. And I want to make the case jokingly that it's maybe even just magic, because if you look at one definition of AI, that's called Tesla's theorem. Larry Tesla is a very famous AI researcher, and he said intelligence, and thus artificial intelligence, is what machines have not yet done, so that we are basically always pushing the boundary. And if you think about it, in the 80s, when we thought about artificial intelligence, we are thinking about chess computers winning against chess masters. Today, we don't think about chess computers anymore when we think about AI. We think this is a solved problem, and it's not really pushing the boundary anymore. And funnily, if you look what some people, how they define magic, I brought you Clarke's law. Clarke is a very famous science fiction author, and he said, any sufficiently advanced technology is indistinguishable from magic. And if you think about it, if you look into your pocket, take your mobile phone, and you would travel some point in the past and would show it to someone, they would think you are some kind of magician. And it doesn't look like technology to them because their concept of technology cannot incorporate this mobile phone. But actually, let's go for a more useful definition. In general, we think about AI always as a very advanced technology, but it's in principle only an umbrella term for a lot of different kind of technologies. So if you use some kind of computer system and data to enable some kind of problem solving, it is, in the most general sense, already AI, and maybe one of the easiest examples that you can encounter every day in your life is if you have a thermostat at your home. That's some kind of an intelligent agent. You give it a task, set a certain room temperature, it takes data about the environment, the temperature, and then it follows its own strategy by regulating the heating to reach its goal. This, in the most basic sense, is AI. But it gets more interesting if we use machine learning, and with machine learning, we get that the algorithm can learn from experience and improve its own performance, and can also tackle some tasks without being explicitly told how to do it. That's one of the most important things about machine learning. And then deep learning is one subset of machine learning where we use some algorithms that take neurons that are loosely inspired by our human brain to tackle the most advanced or most complicated topics today, and all the interesting Gen AI use cases are generally just based on deep learning algorithms. So, what are the key takeaways? Machine learning is data-based pattern recognition. The model that we're training, they don't get any deeper insights about reality, about the subjects that they're studying, so to say. They just look at data, find patterns, and try to replicate them. And when this is done, what they put out is not the final truth, so to say. It's a probability-based output. It can be wrong, and we need to acknowledge that as what's coming out can sometimes be wrong. And these models and algorithms become so complicated that for all intents and purposes, they are basically black box applications where we cannot really understand how all the tiny wheels work together, and it's basically a black box that we cannot really open. So, with this, what is AI literacy? AI literacy has several very important concepts. One important aspect is that is understanding how AI works, understanding limitations and potential of AI, but we also need critical thinking. If we understand that the model will not give us the ground truth in every case, we need to be able to critically examine what the model is doing and what it's outputting. We need the technical skills so that we can integrate it in existing technological ecosystems. We need application and domain knowledge so that we understand how we can use AI to solve our business problems. For example, we need to understand how data works, because the data will very strongly affect how well your AI is performing. We all know the saying, garbage in, garbage out, and it's especially true for AI systems. And when we have AI systems that make decisions or predictions that greatly affect human life, we must be cognizant of all the implications, that we have what the ethical and implications are and how we as humans are responsible for that. So with that, let's discuss what can go wrong when we use AI without sufficient AI literacy. This one is something that we wouldn't call today necessarily AI, but we have all witnessed in our daily life, GPS systems. And some of you, depending on how old are you, might have some recognition of driving with family members, potentially older family members, that were first introduced to GPS when they were already a little bit older. And roughly speaking, I remember two very distinct types. The one person, often more the male counterparts, they were driving, and then the GPS would suggest a shortcut, and this person was always right that this shortcut wouldn't work and was ignoring it and going to the other direction. That's one aspect. The other aspect that can be as dangerous or possibly even more dangerous is blindly following what the automated system is proposing, and that's what we call automation bias. And here is a very flagrant or very shocking example where people really drive into lakes because their car, their GPS system, tells them to drive forward right into a lake. And this can happen with GPS systems, but this can also happen with your company GPT or any other automated system, AI system. So that's something that we need to keep in mind. It's also because AI systems can do something that we don't explicitly tell them how to do. There is some unexpected behavior. And this is also a very shocking example. One company was trying to help their clients by providing a chatbot where you put in what kind of ingredients you still have at home, and it will give you recipes. And one user was saying, hey, dear bot, what I have is water, bleach, and ammonia. And the helpful bot was very supportive and say, how about aromatic water mix? The aromatic water mix is chlorine gas. That's a gas that's used in warfare. That's probably not something that you want to do at home, and you definitely don't want your children to do this at home. And the recipe it got was actually working. So imagine you put this into production, people use it and create chlor gas at home, or chlorine gas. Another important thing is privacy. Everything you put into these kind of systems can potentially leak. Here in this case, it was sensitive corporate data, and GPT got trained on it, and some competitor used ChatGPT and got hand of very sensitive data. People have retrieved working Windows keys from ChatGPT, so it's really, you need to really be careful what you tell your favorite AI assistant. So if we look at these inherent features, we also need, first examples were more like using AI and what can go wrong, but we also need to be cognizant that these new kind of systems introduce new kind of vulnerabilities. So you have traditional software systems, they can be attacked, and we know more or less how they can be attacked. Adding AI system to these systems give you new vectors of attack. So basically, if we know that it's data-based pattern recognition, we can manipulate the data that it's trained on to manipulate the patterns that get recognized. We can, because it's also give predictions on data it hasn't seen before, we can use very peculiar inputs to generate some unexpected behavior. And because these are these kind of black box models, it's very hard to defend against these kind of attacks. So one way how you could attack such a system is data poisoning. On the left-hand side, you see the normal case. You have your machine learning model, you have your learning algorithm, you have your data set, everything works, and it gets trained. On the right-hand side, we introduce poisonous data. And for example, you could imagine you're training you're trying to do a banking app, face recognition instead of a banking card, and then you would introduce maybe my picture for your bank account, and then the next time I go to the bank account, I can take your money. This would be a very easy or easily understandable way to attack it, and you wouldn't probably be too happy if I could take your money. The second kind of way how to attack it are input attacks. Here you manipulate what is fed into the system. Here, for example, we could have self-driving cars, and normally it detects stop signs, knows how to stop at the intersection, but you can trick your system by introducing maybe small stickers, and then the model is not able to recognize it as a stop sign and might run without stopping into the intersection, and this could have very severe implications. Here we have some rough classification how you could perform an input attack. Some are visible to humans, some are invisible, some are digital, some are physical. On the perceivable digital front of view, we could imagine, for example, we had the protests in Hong Kong, if you remember, and then the Chinese government were using facial recognition to understand who was protesting, and many of the protesters used special clothing, sometimes hoodies, sometimes glasses, and they were able to completely disturb the facial recognition, and so they were able to leave without getting arrested. So, what is important to take away? AI is powerful and it's here to stay. And to misquote Uncle Ben from Spider-Man, with great power comes great responsibility and great challenges. And these responsibilities and challenges can at least partially be addressed when we have a conscious interaction with AI tools. And AI literacy is a very important aspect of this. And with this, I come with the actual gift that we brought you. As part of our project, we have developed a certificate which is free for everyone. You can test your own data skills, AI skills, and you even get a certificate from us. If you're interested and want to learn more about it, we have a booth just outside of the main stage, directly from the main entrance to the right. My colleague, Xenia, is looking forward to talk to you. And with this, I thank you for your attention. And yeah, thank you.